Right. So object state, right? So let's just take a look at anything I might have forgotten. Oh, interesting. Yes, static properties, attributes, and dynamic properties. Dynamic properties are any kind of current values, right? Any kind of current values. But again, if you want to build a thermostat which recognizes absolute zero temperature, right? That absolute zero temperature could be some kind of a constant, right? You don't want to make it a variable, or just like 0 degrees Celsius, you know, the freezing point. That could be just a constant. So naturally, a lot of static properties could be made constants. And if you have a constant, it's very natural to make it static. And when we say static, it's really, for instance, something like tax rate, right? Your state tax rate, for instance, can be made a constant, right? Could be made a constant. You know, maybe not a terribly good idea because that could change. But you know, you could view this as something that needs to be shared by all of the sales. So in that regard, right? If we just maybe I can duplicate this view one more time. Right here. So if you create this, let me see. If you say in our software, right? If we say, I kind of like better this thicker pen. New sale, right? New sale. And you create this new sale, and perhaps this is Java environment. So this is new sale. You create this object. I don't know if it takes any input parameters to create, but the object gets created in memory by new. Okay. So we can like draw a chunk of memory and realize that this is where our object is right here. So we have the object with all kind of parameters inside, and then at the same time we can have a system that has multiple users, or an application server somewhere connected to the web server that accepts multiple orders from multiple customers at the same time. So it's possible to have multiple instances of this sale in memory at the same time, right? So this is just one of them that we can see, but at the same time there could be multiple instances at the same time. And so therefore we want to place this piece of data, such as tax rate, right? Maybe we don't want to make it part of each single object. And so essentially our software, the methods that work with each individual sale will be just referring to this static instance of the text rate anytime we need to compute something that involves the tax rate, right? So this tax rate can be made a static object. And of course, when we define this, when we say class sale, right? Class sale, okay? And this is obviously supposed to look like a curly brace, right? So what we say when we define this tax rate, we say tax rate. What we do, we simply say that it's static, right? As soon as you name something static, it's taken out of the scope at runtime of the actual object and placed in a separate memory which is shared by all instances of this object. So we say that static tax rate could equal whatever, 0.7, whatever you use for your tax rate, right? And you initialize it, and this is fine. It's also very advisable to keep this tax rate in, again, speaking of Java syntax, this would be final, right? Make it final. So that would make it even easier to work with, because then your compiler will place this tax rate in constant memory, and at runtime it will be preserved from any kind of modifications, right? So even computer virus could exploit perhaps changeable tax rate if it was unprotected in some way. So making things constant adds both security, optimization, efficiency, speed. So this is a very good idea. At the same time, if you make this tax rate for our sale class, right? If you make it, if you don't have the luxury to make it final, right? So if it cannot be constant, then generally speaking, especially in this environment where we have multiple customers creating those sales in different areas of memory on our application server, and if you need to actually update it and change it, because maybe you want to serve, I don't know, different states, and those different states will have different tax rates, so you can no longer make this tax rate final, unchangeable. Then you have a challenge to changing it. But if you make it static and not final, right? So the final isn't there. Then it presents a danger in multi-threaded environment, multi-user, multi-threaded environment, that generally speaking, static variables, if they're truly static and out of the context of individual object, it is usually a threat to threat safety in multi-threaded environment. So it's easy to think about static pieces of data, but you should actually, unless they're constant, constants are perfect and always welcome and always good things to use and include anywhere you want. But if you have to deal with static data, which is static, it's usually a big signal to a lot of threat safety issues, and typically require a lot of extra careful and extra long sometimes programming. So because before you can update it or even try to read the information during the update, you could be getting garbage information. And of course that garbage information would create an incredibly hard to reproduce bugs. Right? So all of a sudden, you'll realize that something as simple as tax calculation failed because it produced some crazy number. And sometimes things can fail even because it could be some garbage in memory. So it's a huge concern. So I think when you just think about static properties, my advice to you, unless you can make them constant, be very careful about casually using them in your design and your programs, right? It may be a significant, and even if today you think about an application which runs only for the single user, what if you have a successful startup and some big company buys your startup and now they want to take it to a multi-user environment? Or you were trying to, you built some kind of financial calculation engine on the desktop and made it attractive enough. So again, your startup company was bought by a bigger company, and now this bigger company wants to take this desktop application on the web and make it scalable for now thousands of users. All of a sudden, if you didn't use any static properties, static variables in your classes, you're fine. It will be scalable, it will be safe. But if you did rely a lot on static variables, all of a sudden it's almost like a rewrite. It's definitely going to be a different version. It is going to be different kind of software when you now have to move from this like single-threaded, single-user environment to multi-user environment. So always write with expectation. When I write any code, I always look at it and I think, will it be threat safe? If it was running somewhere in the application server connected to the web server, and sometimes the answer is yes, And sometimes the answer is no. But I would like to know the answer as I'm writing the code, as opposed to, making some difficult, or being forced to make some difficult choices with them later on. But when we talk about object state, in general terms, we need to compare those static properties and dynamic properties, and essentially keep ourselves aware of the issues with them. All right, so interesting term here, fixed set of properties. Fixed set of properties. I would like to mention a few things about this right here, again, in some of our demonstrations. If you think about, so again, perhaps we have some kind of class, right? And sale is, since we started talking about this sale environment. So we declare some data. We create some data attributes inside this class, and when we instantiate this object in memory, right, it gets created somewhere here in memory, and so obviously in memory these pieces will exist as physical integers, booleans, double, floating point numbers, and so forth. All kinds of data. Right. So when we actually instantiate and this object gets into memory, so this is sort of like more or less easy to picture, but at the same time, don't ever make a mistake that if I also, again, if this is a Java type of environment, I can add here an array list, right? Array list of line items, right? Line item, okay? And I can create the sale object with no line items in it, empty array list. But if I will be adding somewhere during the life cycle of my sale class, as I'm adding new line items, I want you to realize that what happens is that, of course, array list is a separate object in the first place, and then somewhere here what it does when new line items are created, they're created elsewhere in memory, like those new I'll actually annotate all of these objects as new, right? And this will be my new sale. This right here will be, I don't know why it keeps, okay, good. New sale, right? New array list. At some point, this is what happens in runtime. At runtime, my program says new array list, new sale, new line item, right? Another new line item of the sale, and that's where objects end up in memory, right? Different places in memory. But when this new array list is created and is populated with new array, individual elements of this array list, these new line items, remember that those exist independently. The size of the original object, which is this array list, never changes. So basically, what happens is that it dynamically allocates space to hold these line items, but essentially it somehow references the first one on the list, right? And then it knows where and again, this is not exactly how array list works, but essentially it's a sequence of things. Just be aware that the actual size, right? The size of this list is the same the actual object has the same size. It never changes. What changes is that somewhere there is dynamic memory that it actually allocates, and that area can grow. But this object just managing that specific dynamic memory area. Right, so it's just a sort of like an interesting aspect of it when we say on this slide fixed set of properties. ArrayList always will have a set of internal data. It's perhaps I think maybe in this presentation or later on I have a demonstration like of a stack class that has the area where individual items are populated and the integer variable that specifies location of the element on top of the stack. And it never changes, right? Once the object is created, it's the same size. Another aspect of it is that such object as ArrayList, which can grow and shrink logically, but physically it's using some kind of dynamically allocated memory where things are being allocated, and most likely actually to sort of like to let me now that I'm thinking about it, I'd like to show you what really may be happening here. Was just actually, let me start from scratch. Let me try to picture it like one more time. So say first I create an array list, right? Array list. We create new array list, and it gets its memory somewhere here, right? And it has basically a reference to area which will be dynamically allocated. Okay, so then we say new line item and add it to the array list. So line item will be created somewhere here, and we can say new line item multiple times, right? We can say it multiple times and say we can create 3 of these line items, and then we can start adding these line items, already existing line items, to this array list of line items. Well, what it's going to do, it's going to dynamically allocate an area which has enough space to reference these line items. So basically it's going to say, okay, so this is the address of this one, this is the address of that one, and this is the address of this one, right? So see, this whole area, which I would like to highlight right here, this entire area did not exist when I just created the array list. This area is managed dynamically, right? But it really does not affect the initial size of this object in memory. It only has a reference which points to where this dynamic area in memory is located, right? So just be aware of those things. The great news about ArrayList is that you don't have to worry about this area. It is managed by the ArrayList itself. You don't have to worry about it, right? So this piece is completely managed by the ArrayList. It's responsible for it. It knows how to allocate it, how to deallocate it. It knows where to go to ask for that memory. You don't have to worry about that. You just have to create new ArrayList and say, now I would like to add these 3 line items to it, and it will just do everything that it's supposed to do to manage memory, right? So once again, I just wanted to clarify, and by saying fixed set of properties, I just say that if you look at the size of the actual ArrayList object in memory, regardless where it has 0 items in it or 3 items in it, its initial size right here is exactly the same, right? Because if then I create just another line item, which may be over here, it may have already enough space on this dynamically allocated area, or it will simply just go, right, and reallocate this dynamic area someplace else, right? And what it's going to do is just allocate more space and then repoint. Basically, repoint, let me just use a different color, right? Repoint these 3 elements to point to the original 3, right? and then use a new one to point to the new one right here, right? And then it may actually return, right? It may return this back to the system and say, I no longer want to use this. Now I'm using new area, and of course, right? And of course, this is now pointing not to this now deallocated area, rather it's pointing to this newly allocated. Let me just switch back to this color, right? And so now it's referencing this brand new area and no longer using any of the old stuff that it was using associated there before, right? So completely reallocated this dynamic area, repointed all elements back to the original objects so that the objects are all accounted for. But at the same time, again, notice that the size of the original object has never changed. It's the same, right? All this memory manipulation happens elsewhere, but the size of the original ArrayList object is exactly the same. It's fixed. It has the address of this dynamic area, and that address can be updated, pointing originally here and then going to a different area later on, but that does not affect the size of the ArrayList in its physical size in computer memory, right? So that's why you should think about objects as a fixed set of properties and not something that can actually stretch or shrink because it magically changes its footprint in memory, right? So it's all basically some complex manipulation of dynamic memory that allocates memory dynamically and deallocates it dynamically. But when we create our objects, they're all fixed size. They're just same size from the beginning of its life cycle till the very end of it, right? So just wanted to essentially make sure that we emphasize that.